What's up, mathletes? This is section 2.4, solving systems of equations graphically. Let me explain to you what that means. You might remember from Algebra 1 that a system of equations is two equations that are being considered at the same time. So let's think about this y equals 3x plus 2 and y equals 2x. What values of x and y are going to solve them, are going to be true in both equations at the same time? And there's actually at least three different ways of figuring this out. And we're just going to cover the first way today, and that's graphically. So basically, the idea is if you graph them both, where they intersect is going to be the solution. So you can see the red line is graphed here, the blue line is graphed here, and so then you got this, the intersection is over here at once, and there's only one solution. It occurs once at -2, -4. This is not set notation. This is actually describing coordinates, a location on the graph. At -2 on the x-axis, -4 on the y-axis, boom. And you can check. You can put -2 in for x, as you do in both equations here, and -4 in for y, and you can see that they're both true at the same time. Yay. Let's do the same thing again here. A bit trickier to graph because we got a fraction, but that's okay. We got y, the red line is y equals 1/2 x plus 2. The blue line is y equals -2x minus 3, and they intersect once right here at -2, +1. There's only one solution, and it's right here. And you can check, you can see, you can plug both -2 in for x and plug 1 in for y, and you can see that the -2, 1 works. And I want you to tell me what's underneath that red dot when you get a chance. All right, let's bump it up. Things are going to get a little bit interesting when the lines are parallel. You can see if we graph in red y equals -x and y equals -x plus 3, they've got the same slope. All of a sudden, there's no intersections. And no intersections mean no solutions. So there's actually nothing to report as an answer. There's an empty set. What's the answer to this question? There's nothing. There's no intersections, no solutions. Things get really bizarre when you start graphing two lines in the same location. Here's y equals x plus 1, and I sneakily subtracted 1 from both sides to get a different version of the same equation, y minus 1 equals x. You can see it doesn't matter how sneaky I am, they get graphed in the same location. They are overlapping. They are not separate equations. All these other lines, you could call them separate. Here, so these two are two separate lines, these two are two separate lines, and these are two separate lines, but these are not separate. When you graph them, they are overlapping. And there's actually an infinite number of solutions that you can have, because why? There's an infinite number of intersections. These two lines intersect at every point along the line, and I'm listing some of them out. For example, 0, 1 is on the line. 1, 2 is on the line. 2, 3 is on both lines. 3, 4 is on both lines. So I'm started to list them out, but actually anything that satisfies the top is also going to satisfy the bottom. How many solutions are? There's an infinite number of solutions. Trippy. So therefore, because there's an infinite number of intersections. When we start talking about these things, we can ask two questions. We can ask, are there any intersections on the graph at all? Like there were not. The answer is no over here because there's no intersections. There's no solutions. And then, are they separate? That means, are they non-overlapping? So here, this is actually like a cat and mouse race. The two guys were chasing each other. One was named Rich, one was named Julio, and you'll actually see the video of these guys chasing each other. This is on SportsCenter, and I couldn't help but turn it into a Desmos activity. You'll see tomorrow. You'll actually see slow Rich and fast Julio. Rich is even given a 10-yard head start in this one, but you can see there's only one solution here. And so, the first question is, are there any intersections? Yeah, there is. There's one. You can see it right here. Are there any solutions to the system? Yes. And so we're going to call that consistent. Down here, what if they were running at the same speed? You could say, are there any intersections or are there any solutions? The answer would be no. We call that inconsistent. The next question is, are all the lines separate? Or what you might say non-overlapping. Yeah, these are two separate lines. And these are two separate lines, but over here, so the answer is yes. And if the answer is yes, we call that independent. This line is independent from this one. These two lines are independent from each other. However, if it's overlapping, then the answer to this question is no. And we call that dependent. You can see these are not separate. They are, in fact, overlapping here. And what if we had like 3 people over here? This is a fourth case that's rarely discussed. It's not even on Alex. You won't see it. But I just wanted to like complete the chart. So what if you had 3 different lines, Rich, Julio, and me, Mr. B, on green over here? There's some overlapping going on, yes, but there's still no solutions because the 3 lines don't intersect at the same place. Anyway, these two are what we would call dependent, when the answer to this is no. Are the lines separate? Are all the lines separate? No, not all the lines are separate. So you've got some overlapping going on. We call that dependent. So this is consistent because there's at least one solution, but it's also dependent. And this is inconsistent dependent. So, some definitions. We've got a system of equations, or multiple equations that are being solved, graphed, or considered at the same time. A solution to this system would be a list of numbers that make all the equations true simultaneously at the same time. The big idea is that we're solving these graphically, so intersections on graphs are going to be the same as solutions to the systems of the equations. You find an intersection, it's the same as a solution. If you want to be consistent, is anything that answers yes to this question. Are there any intersections in the graph? Yes. A consistent system is a system that has one or more solution. The opposite of that is inconsistent or not consistent. Therefore, it's something that has no solutions. Then we got 2 other opposites here. Independent is a system with all separate, non-overlapping graphs, and dependent is a system with overlapping graphs. And I just wanted to say, while I'm wrapping things up, that I live in Mount Airy at the time of this recording, and West Mount Airy is my neighborhood. And so that's your audio check for today. Make sure you report the red dot. I think that's all. Look at this. Oh, nothing to see. I'll see you in class.